IC engine. So myself K. Sudhakar, Assistant Professor, Department of Mechanical and Automation Engineering, PSN College of Engineering Technology. So now we are going to see what are the fuel systems in IC engine. First of all, what is the fuel system is IC engine means it is an internal combustion engine. More or less the world is running under the engines only. There are a lot of types of engines are there. So now we are going to see the IC engine. What is the internal combustion engine by using air and fuel. What are the engines are available we can see. So first one is a simple carburetor. Simple carburetors will basically work on the depends upon the Bernoulli's principle. Whenever the faster air moves, the lower the static pressure and higher its dynamic pressure. And then second one is the throttle linkage does not directly control the flow of liquid fuel. Okay, so first the carburetors work on Bernoulli's principle means whenever the air faster moves, the pressure will be static only. When the static pressure will be high, low, and then the dynamic pressure will be high because of the air flow moves. Okay, so let us see the simple carburetor. So this is a schematic diagram of the simple carburetor. Here we can see the fuel supply. This is the starting point of the left corner is the starting point. So there is the fuel supply line. In that it goes to the reservoir. There is a fuel tank or carburetor 14 chamber. So the 14 chamber is called as a reservoir. In 14 chamber there is a floating device will be occur. It is like in shape of a rectangular or square or hexagon or anything. So and then here we have a choke and we have a venturi type passage, and here we have a throttle and we have a mixture to manifolds. So now let us see the process of the simple carburetor. First fuel is entering into the 4 chambers. In 4 chambers the fuel will be deposited, stored like that. So after the 4th chamber, the 4th chamber is connected with the accelerating cable. So whenever we are giving accelerator, the 4th chamber will activate. So the 4th chamber like a floating device in the water like that. So whenever the throttle 4th chamber is open, the fuel will enter into the throttle area. So at the same time, the air will move from the top of the carburetor. So in the top of that, there will be a choke also will be there. So due to whenever choke is used to increase the air into the venturimeter, because of we need a high pressure we need to start the engine. So for that we are using the choke valve. So from the initial stage, whenever the choke is off, the throttle will be fully closed. Whenever the choke is on, the throttle will be full open. While full open means the large amount of airflow is entering into the carburetor through venturi. So in venturi, there will be a fuel and air will be mixture. So the venturi is conversion of diversion conversion analysis like that. So from the top of that it becomes as a high pressure, and it will in between that it will be a pressure will reduce, and finally the pressure will go low. So after the entering air to the throttle, so the throttle is connected with the accelerating or ideal speed adjustments. And the throttle is connected with the accelerator. So whenever accelerating the throttle will move open. So the throttle will be the form of a disc or round type. So these are the basic principles. After the throttle, the air-fuel mixture will be entering into the engine manifold. Okay. Next then, this results will drop in the rapid drop in pressure. That's increase in negative pressure. So that it allows fluid lift the fuel from the carburetor 4th chamber and sprays into the incoming air. Okay, so whenever the pressure will negative drop, the fuel supply will lift the carburetor 4th chamber. So the fuel will enter into the carburetor. After the entering of air fuel mixture, the mixture passes to each cylinder through intake manifolds. So next one, the carburetor atomize and vaporize the fuel mixture according to engine changing operating conditions like accelerating or air condition or cooling or air condition. Okay, so these are the next one is advantages of the carburetor. So first one is a simple design. It is a simple design of carburetor like components like float chambers and throttle, two throttles and one throttle and one choke throttle, and another one is nozzles, ventures. Okay, and then it is economical to manufacture, and it is ease of service. Okay, then ease of service and the local mechanical fixes problems. These are the advantages of the carburetor. And the disadvantage of the carburetors are it cannot provide a perfect air flow mixture constantly because of lag in air intake or because of fuel drops into the carburetor. Due to that, it cannot provide the perfect air fuel mixture. Okay, so and it cannot control the wastage of fuel effectively also. So and then more number of parts and some complex systems which makes a diagnosis difficult because some parts will have a complex design means which makes a diagnosis because like a venturi or a venturi we can use the correct proportion of a design. We can easily, because of complicated design, it will take a high pressure or low pressure difference will be, there will be a lack of air. So that's why I am saying. So some design develops problems of vapor lock resulting in engine stalling. Okay, some design means the venturi meter will not occur correctly means the air fuel mixture will be locked. So due to that, the engine will be stalled. Okay. So next we are going to see the fuel injection systems. So first of all, we see the simple carburetors like in bikes. So now we are going to see the fuel injection systems in cars, bikes, cars and heavy duty workers or like that. So first of all, let us see what is the fuel injectors. So fuel injectors is atomize fuel into very fine droplets and increase surface area of the fuel droplets, resulting in better mixing and subsequent combustions. So fuel injectors atomize the fuels into very fine droplets and increase the surface areas of the fuel droplets. Whenever for fuel injector is used for better mixing and subsequent combustions. Okay, so next we are going to see the automation is done by forcing the fuel through the small orifice under hammer, because automation is the mixture of chemical component or mixing of different particles like that. So by chemical automation is done it by forcing the fuel through the small orifice, because of we are giving high pressure to atomize the fuel. So the injector assembly consists of four things. First one is a needle valve, second one is compression spring, and third one is a nozzle, and the fourth one is injector body. So first one is a fuel supplied by the injection pump exerts sufficient force against the spring to the lift the nozzles. So first of all, here we can see the diagram of the first one is the end cap, and then it is adjusting set screw, and then leak of them, and leak of passage, and springs, and this is the spindles, this is the injector body, and the fuel usage, and the nozzle state, and nozzle cap, and the nozzle body. So whenever the fuel is supplied with the engines, the pump exerts, that means pumps moves upward and against the springs. So while adjusting the springs, it will lift the nozzle cap. So after the nozzle cap, the spring pushes the nozzle valve back to the seat. After the injection, after the nozzle cap, the fuel through to the fuel combustion chamber. After that, the spring will return to its original position due to pressure. Okay. So next one is small quantity of fuel is allowed to leak through clearance between nozzle valve and guide for the proper lubrications. So here is the fuel is allowed to leak through clearance between nozzle valve and guide for proper lubrications. Next one is the valve opening pressure is controlled by adjusting the screw. So it's a spring tension. I already told that valve operating. So okay, there is a valve is whenever the valve open, spring will compress. Whenever the valve close, the spring will return. Next one is the nozzle. So nozzle is a part of an injector through which the liquid fuel is sprayed into combustion chamber. Nozzle is a part of an injector through which the liquid fuel is sprayed into combustion chamber. So the nozzle main principle is to pass the fuel from tank to injection. Okay, so nozzle can be should fulfill the following functions like automation and distribution of fuel. So automation is already you know that this is a very important function since the first phase is obtaining power of mixture of fuel and air into the combustion chamber. So automation is a process of mixing of fuel and air in the combustion chamber. And the second one is distribution of fuel. So distribution of fuel to the required areas within the combustion factors. The factor operating areas are injection pressure and density of the cylinder and the physical properties of the fuel. Okay. Next one, penetration of impingement of valves. So this is the penetration means it is the SS fuels or SS dust particles carbon deposits will be stored in the fuel injectors. It will lead to smoky exhaust in the fuel consumptions. Like that, the mixing of fuel and air in case of non-turbulent type of combustion chamber should be taken care by the nozzle. So the mixing air will be case of non-turbulent type, because in the turbulent type will get deposit the carbon deposit. Normal turbulent there will be it should be taken care by the nozzles. So this is the fuel injection system. So it will enhance the performance and fuel economy and insulation and controlling the combustion process. And the third one is preparation of combustion charge like a carburetor. So first one is the performance and fuel economy. For performance only, where you for prefer performance or moderate performance, we are using the fuel injection system, and we will also use for the fuel economy also. Okay. So this can initiating and control the combustion process. The preparation of combustion charge like a carburetor means like a carburetor, it will be regards to preparation of the air fuel mixture also. So let us see what are the main difference between carburetor and fuel injection system. So the carburetor is fully automated by the process relying on the air speed greater than the fuel speed. Okay, so the fuel is automated by the process by relying on the speed, air speed greater than the fuel speed at the fuel nozzles. Okay, so next one is the amount of fuel is drawn into the engine depends upon the air velocity in the ventimeter. So what I am saying means whenever we are using the carburetor, the air speed will be the greater than the fuel speed. But in fuel injection, fuel speed will be greater than the air speed. These are the major difference. And next one is the amount of fuel depends upon the amount of fuel in carburetor. The fuel drawn is depend upon the air velocity of the ventimeter. But in fuel injection, it is the delivery of the engine by the pump, by using the pump to control the fuel delivery in the engine. These are the major difference between the carburetor and the fuel injection systems. So let us see the components of the fuel injection systems. First of all, right corner is the fuel oil tank. Here only we store the fuel for a supply. So from the fuel oil tank, it goes to the filter. In filter, it is used to remove the unwanted particles from the fuels, like major particles like dust and corrosion, like that. After the filtering, it transferred to the transfer pump. So in transfer pump, the transfer pump is used to transmit from one place to another. So the pump is transmitting the filtered fuel into the fine filters. Why are we using the fine filter means because without fine filtering means there will be some amount of dust or carbon deposit, will be anything will be stored in the fuels. It leads to improper combustion in the combustion chamber. So for that only we are again we are filtering, we are giving filtering. So that is called a fine filtering. After the fine filtering, it moves to the pumping head. In pumping head, the fuel will be stored. Okay, so for pumping, for activating the pumping head, we need a cam box and a governor. So, okay, so the governor is based upon the rotation motion. It will rotate due to rotation motion. The cam will activate. Okay, so the governor is based on the throttle or what are the engine conditions you have given. Like that depends upon throttle and the governor will function. Due to governor rotation, the cam bus will push the pumping head to pass the fuel to the fuel injectors. After the fuel injector receive, the fuel injector will spray to the injected or spray to the engine inlet intake manifolds. Okay, these are the simple representation of diesel engine fuel engine system. Okay, they usually used in the cars and heavy motor, heavy trucks, loads, and we can use it here. See. Okay, so what are the now? Let us see the what are the parts is there. So first is a fuel tank. So fuel tank is to prevent fuel filters will be attached with the fuel tanks. Fuel tanks after the fuel tank, fuel filters will be there. So the fuel filters will to prevent the dust and abrasive particles from the pump. And the fuel feed pump is used to supply the fuel to the injection system. So under the injection pump is used to pressurize the fuel for the injection. And then governor to used to ensure that amount of fuel injected is in the accordance with the variance of load. So the governor ensure the amount of fuel injected. It is based upon the variation of load we are giving. Okay. After the variation of load we are giving governor actuated, the injector takes the fuel from the pump and to the combustion chamber. Okay, and next we are going to see the classification of the injection system. So first is the injection is classified into two types. First one is the air injection system and solid liquid injection system. Let us see the first one, air injection system. The air injection system, there is a 6 points to consider. First one is accurate metering. Second one is timing the injection, and third one is a proper control of rate of injection. And fourth one is proper spray pattern, and sixth one is uniform distribution. So in the engine energy system, the accurate metering is to identify the how much of fuel injected in the combustion chamber. So next one is the timing the injection of the fuel economy is how the in combustion chamber we need a exact or timing air fuel mixture. For the air fuel mixture, we need a timing of injection. Next one is a proper control of rate of injection is if you are not using the proper control means the rate of injection will be maybe high or low due to it leads to the improper combustion process. So for that we need a proper control. And what is the proper spray pattern is also is from the fuel injector after the fuel taken from the fuel head, pumping head, and the fuel injector rapidly spray the fuel into the combustion chamber. Before that, before spraying, the air and fuel will be mixture and it passes through the intake manifold. Okay, next one is a uniform distribution of fuel data throughout the combustion chamber. So whenever the uniform distribution of fuel drops throughout the combustion chamber. Okay. Next one is fuel is administered air system. Fuel is forced into cylinder by means of compressed air, because in air engine system the air will be passed in because whenever the poor mixture of air it leads to high effective pressure. Okay. Then the next one is it has the ability to utilize high viscosity, because high viscosity means the air flow will be struggle. It can be flow smoothly to the cylinder, so that we can easily use less amount of fuels to the air fuel mixture. Okay. Then solid injection system. In this system, the liquid fuel is injected directly into combustion chamber without aid of compressor air. So, okay, in this system, liquid fuel is injected directly into combustion chamber without the aid of compressed air, because in air system we need air fuel mixture, but in a solid engine system we need only fuel only, we don't need the air to mixture. After the fuel enter only the air will be mixture. Okay, so there are the 4 types of injection systems. First one is individual pump and nozzle system, and the second one is unit injection system, and the third one is a common rail system, and the fourth one is distributor system. So let us see the types of the injection system. Solid system. First one is individual pump and nozzle system. In the system, for each injector we have each cylinder, each pump, because this is a individual pump means for a single injector we have a single pump. If we have 2 injectors, we have 2 pumps. So for each and every injectors they have individual pumps. So it is that injectors and nozzle injectors and pumps will placed in parallel to each other for a smooth construction, because there will be a low pressure pump is also there will be high pressure pump. From fuel tank, the low pressure pump is pumped it moves to the high pressure pump. The high pressure receives the fuel from the lower pressure pump, and it will pressure the fuel highly to the injectors. So and then the injector will spray to the combustion chamber. This is called individual pump and nozzle system. Next one is a unit injection system. In unit injection system, unit means a combination of 2 areas the unit. So here also the pump and injector is conducted in a single hosing only. If any 5 type of injection system is also that means there will be for each injector, the injector pump will be attached within a single hosing only, because it will have a low pressure pump at the bottom of level, and before injectors will have a high pressure pump, and pump will have a low pressure pumps. Okay, low pressure pump supplies the fuel to the high pressure pump. In injector, high pressure pump will be automatically activated, and it gives a high pressure to the spraying into the combustion chambers or intake manifolds. Okay, so and then fuel is brought up and injected by the low pressure, and there is a proper time, and the rocker arm actuates the injection fuels in the cylinders. So next one is the common rail system. Common rail system is a high pressure pump supplies fuel under high pressure to a fuel header. Okay, so next one is high pressure in the header forces the fuel to each of the nozzles located in the cylinders. Okay, high pressure pump supplies fuels, high pressure pump supplies fuels, and under high pressure to high fuel header. So in common system there will be a more than 2 or 3, 4, 5, 6 will be there. So each everything more than 5 we have a 6 injector means 6 cylinders will continue in a single header only. So the header will pass the fuel to the all injectors. This is called a common rail system. So here let us see that high pressure pump in the head forces the fuel to each of the nozzles located in the system. So the high pressure in the header forces the fuel from the high pressure pump to the nozzles wherever the cylinder is located. It will pass from the fuel will pass from the header to the cylinders. At the proper time, the mechanically operated valve allows the fuel to enter cylinder through nozzles. Okay, at the proper time, the mechanically operated valve allows the fuel to enter the cylinder through nozzles. Okay, so next one is the amount of entering cylinder is regulated by varying the length of the push start stroke. So in previous systems we can see the bottom of the low pressure pump will be located and the high pressure pump will be located next to it or top of the injectors. But in common rail system there will be no use of low pressure pump, because there will be a large amount of injector size installed, so that by which low pressure cannot circulate correct proportion of fuel supplied to the each injectors, so that we are using the high pressure pump to regulate the proper control of fuel to the injectors. This is the common drive systems. So let us see the distributor system, final one. In the system, the distributor is by distributing from the one to another one. The same principle is applying here. Here we see the diagram of the first one is the low pressure pump is there. From that low pressure one, there is a pump is used to passes from low pressure to distributor. In distributor, there will be a shaft is attached to that. Due to shaft rotation, the distributor will process the fuel to the injectors. And distributor lines will be high pressure lines. Because of that, the distributor will regulate the distribution evenly to the correct time and correct arrival of the each cylinder. Because the 6 cylinders will not operate in the same time. One cylinder will operating at TDC and one cylinder will be at BDC. These are the major difference. Okay. This is gonna, so that was in the system. The pump which pressurizes the fuel and also meter times it. The fuel pump meter the amount of fuel supplies rotating distributor at a correct time arrival to the each cylinder. So this is the injection stroke per cycle of pump is equal to the number of cylinders. So this injection strokes per cycle for the pump is equal to the number of cylinders. So there will be a one metering element in the each pump. So these are the distributed system. So now we have seen the what are the fuel systems in the IC engine. So in IC engine there is two types. There is a SA engine and a CA engine. There is a spark ignition and a combustion engine. So in spark ignition, the spark plug is used to produce electricity to the and to fire. So in combustion engine, the fuel injector is used to spray the air fuel mixture into the combustion chamber. So these are the major difference in the SA engine and the CA engines. Okay, so let us see the growth of little bit. Okay, this is a simple counter. Fine. Once again, I am saying that this airflow coming up from the top of the strokes will be activated. Choke will be active or non-active. So it by air will passes through the ventilator. At the same time, the fuel supply will passes through the fourth chamber. The fourth chamber, whenever the fourth chamber will have high pressure, means the fourth chamber will close the particle. Whenever the fourth chamber will have a low pressure, means the float will uprise. Due to uprise, the fuel will enter into the throttle. So during the entering into throttle, the airflow also passes through the venturi through throttle. In throttle, there will be a air fuel mixture combination. After the air fuel mixture, due to accelerating, the air fuel mixture will passes to the intake manifold. Okay. Next one is the fuel injection system. In fuel injection, we used to see the fuel injector. What are the fuel injectors is there? This is a fuel injector is a spring type valve, so it can improve the leak proof and income is there. Whenever the spring retract, whenever spring compress, the nozzle cap will open, the nozzle will activate. Whenever the spring retract, the nozzle cap and nozzle valve will be closed. From this the fuel will be supplied or not. So next we have seen the fuel injection systems. In fuel injection system, you see the fuel oil tank and filters and the transfer pumps and fine filters and fuel injectors and the return link from the fuel injectors. So from the fuel tank, the fuel will go through the filters. In the filter, there will be a clean filter, and then it will transfer to the pump. From the pump will transfer to the fine filters. In fine filters, the remaining amount of minute nano dust particles or abrasive materials to be removed, and it passes through the fuel injectors, and the fuel injector will passes through the engine, and the liquid will be attained. So these are the fuel injection systems. So there will be we seen the types of the solid air type and solid type. In airtight, the compressed air will be used for the to the force into cylinder. In that airflow mixture will be occur. In solid system, we will not use the air. Without air, we are using the fuel directly to the combustion chamber. In that, we see the 4 types: individual type, unit system, the combination system, and distributed systems. Okay, so I hope that you can understand that. We'll meet you soon. Thank you.